Good morning, dear students.
Good morning, ma'am.
Yes, good morning. Okay, so did you all practice yesterday the four name reactions: Rosenman reduction, Stephen reaction, Itard reaction, and the last was Gatterman-Koch reaction. Any doubt in that? Any doubts? Okay. So these are specifically the preparation of aldehydes. Okay. So these are specifically the preparation of aldehydes. Okay. Others, so please go practice. Okay. Unless and until you practice those reactions, you will not be perfect. So you have to keep practicing it. Okay. In a one day, you will not understand the name reactions. So you have to keep on practicing those name reactions. So as I discuss every time, name reactions are very important. Okay. So name reactions are asked during exams for 2 marks. So they can ask the explanation and with the example. Okay. Any of the name reaction. So these are some of the important name reactions which I have told you. So we have seen the preparation of aldehydes from acyl chloride, then from nitriles and esters also. Okay. Then from hydrocarbons, right? That is by doing the oxidation of methyl benzene with chromyl chloride, which is called as the Itard reaction. Okay, it forms a chromium complex in between, which is an intermediate step. Okay, which upon hydrolysis will give you benzaldehyde. So you are getting a aromatic aldehyde from Itard reaction. Then we have discussed about the chromic acid oxide also. Then we have seen the side chain elongation, how we are doing, how we are manufacturing benzaldehyde, okay, commercially. So commercial method means industrial method at a large at a large scale. Okay, at the large scale, when you want to prepare benzaldehyde, so this method can be used. Okay, so by doing the side chain chlorination of toluene, so we are taking a toluene molecule. Okay, we are taking a toluene molecule that is a methyl substituted benzene. So this upon doing chlorination, so we have done a controlled chlorination. That is two molecules of chlorine in the presence of sunlight. What happens? Two hydrogen atoms are replaced by two chlorine atoms. You get a benzyl chloride. This upon hydrolysis at 373 Kelvin will give you benzaldehyde. Okay, so this is the commercial method, that is a side chain chlorination followed by we are doing hydrolysis. Okay, so then we had discussed about Gatterman-Koch reaction. So what is Gatterman-Koch reaction? So in Gatterman-Koch reaction, we are taking a benzene. Okay, we are taking a benzene. Then we are reacting our benzene with carbon monoxide in the presence of hydrochloric acid. Okay, and anhydrous aluminum chloride, or we can take cuprous chloride. So in cuprous chloride, what is the oxidation state of copper? Can anyone tell me what is the oxidation state of copper in cuprous chloride? Yes. What is the oxidation state of copper here? Chlorine. What is oxidation state of chlorine is -1. There are two, right? So this becomes -2. So this is +2. Okay, so copper is +2. So the oxidation state of copper is +2. Okay, so it is cuprous chloride. So cupric, whenever you have cupric, then it is +1. Okay, now here, suppose this CuCl. What is the oxidation state of copper here?
1 plus
Uh,
1.
yes, +1. -1 +1. The whole charge will become 0. Right. So this is a cupric chloride. Okay, this is a cupric chloride. This is cuprous chloride. Okay, fine. So we are making use of this reagents and we obtain a benzaldehyde. So this is a Gatterman-Koch reaction. So next we are going to discuss the preparation of ketones. Okay, next we are going to discuss the preparation of ketones. So the first preparation is from acyl chloride. Okay, now you know what is acyl chloride. R C double bond O Cl. Okay, so this is a acyl chloride. Okay, or it is called as the acid chloride. Acid chlorides, or it is called as acyl chlorides. So by taking starting product as acyl chloride or acid chloride, you can prepare your ketones. Okay. So what we are doing, ketones, okay, it can be prepared from this acid chlorides, okay, by treating it with dialkyl cadmium. So we are going to take a dialkyl cadmium, okay, and this is obtained. How we are going to obtain this dialkyl cadmium? By reacting the cadmium chloride. Okay, by reacting the cadmium chloride with Grignard reagent, we are going to get a dialkyl cadmium. So this is our dialkyl cadmium. So how we are going to get this dialkyl cadmium? Dialkyl cadmium is made to react with what? Grignard reagent. Okay, after reacting the cadmium chloride. Okay, so after reacting the cadmium chloride with Grignard reagent. So what is our cadmium chloride? Let me write this only. Okay, so what we have to get? We have to obtain dialkyl cadmium. How? Cadmium chloride plus Grignard reagent. Okay, RMGX is Grignard reagent. So when it reacts, you get CdR2 plus 2MgXCl. Okay, so this is our product. Okay, so this is our dialkyl cadmium. So this dialkyl cadmium, this I'm going to do what? I'm going to treat it with acyl chloride. Okay, this I'm going to treat it with acyl chloride. Now, next step. Okay, the next step. So here you can see. So Grignard reagent 2RMgX plus CdCl2. Okay, that is your cadmium chloride. Cadmium chloride will give you dialkyl cadmium. Okay, dialkyl cadmium. Got it? Fine. Now in the second step, what we are doing? We are going to take a acyl chloride. We are going to take our acyl chloride. Okay, two molecules of acyl chloride reacts with two molecules of alkyl cadmium. Okay, two molecules, that is a alkyl cadmium, two molecules of alkyl cadmium react with one molecule of dialkyl cadmium to give you what you will get. So your Cl is the good living group. So your Cl is the good living group. So what you will get? So 2R R. Okay. So two, we can take R dash. This is as R dash because there are two R, right? So this 2R plus cadmium chloride plus cadmium chloride. So what is happening here? Your Cl is a good living group. So Cl is replaced by this R2. Okay. So this is the product. That is your ketone. So this is your product ketone and your cadmium will react with the 2Cl and will form cadmium chloride. Is it clear? Yes. So this is our first preparation from acyl chloride or acid chlorides. Okay, from acyl chlorides or acid chloride. So let us take example. Is it clear? Let us solve examples.
Yes, ma'am.
Okay. So, so I hope you are noting down the reactions. Okay, fine. So let me give you an example. So you need to tell me the answer. Okay. So 2CH3 C double bond O Cl plus I'll take it this as CH3 twice cadmium. Okay. Can you tell me the product? Yes, what is the product? Cl is a good living group. So what will happen? Cl will form
2CH3.
2CH3.
Single bond C.
Hmm.
Double bond O.
Hmm.
Single bond CH3.
Yes. So this is a ketone.
Ketone.
What is the name? Acetone.
Yes, ma'am.
Okay. Plus CdCl2. Very good.
Cl2.
Yes, very good. Okay. So like this. So this is a starting product is our acetyl chloride. The starting product is acetyl chloride. So when this acetyl chloride reacts with the dimethyl cadmium, okay, we have taken dimethyl cadmium, we are going to get acetone. Okay. Let us take one more example. Let me write it here. Okay. So the name of this compound is benzoyl chloride. It is benzoyl chloride. So benzoyl chloride reacting with dimethyl cadmium. Dimethyl cadmium. Yes. Can you give me the answer? What is the answer? Product formed here. Benzoyl chloride reacting with dimethyl cadmium. Don't think much. Your Cl will be replaced by this CH3. So what it will be? So this is the benzene ring, C double bond O and CH3. So this is what? What is the name of the compound? Anybody knows? It is acetophenone. Okay, it is acetophenone. Fine. So this is the uh, product obtained. Got it? So this is like this. We can prepare both. Okay, we can prepare our ketone, aliphatic ketones also and aromatic ketones also. So
Ma'am,
by this,
CH3 twice now, ma'am. We have just replaced only once.
here you see
Okay.
balanced, right? So it is balanced. Okay, so it is a aromatic ketone. So by this, what we can do, we can obtain both type of ketones, that is aliphatic ketones also and aromatic ketones also. We can prepare from this method. Okay, so this was the first preparations of ketones. Okay, is it clear? So next we are going to start with nitriles. So second preparation of ketone is from nitriles. Okay. So nitriles, we reacted with what? We reacted with Grignard reagent in the presence of dry ether. So this is our Grignard reagent. Let me write it Grignard reagent. Okay. So Grignard reagent in the presence of dry ether. So nitrile, what so nitriles, okay, react with Grignard reagent in the presence of dry ether and gives you a addition compound. Okay, it gives you addition compound which upon hydrolysis, okay, which upon hydrolysis will give you ketone. Okay, which upon hydrolysis will give you ketone. So nitriles, when reacted with Grignard reagent in the presence of dry ether, gives you a addition compound. Okay, this addition compound will undergo hydrolysis to give you ketone. Okay, so let me write the general reaction here. So nitrile is R. So this is the generally, this is the nitrile and your Grignard reagent RMGX. So let me take this as R and let me take this as R dash. So this in the presence of dry ether. So how this reaction undergoes, okay? So general reaction is not given here. So you can note down this, okay? It will be easy for you for understanding. So what happens here? So this is a nitrile. Okay, this is a nitrile and this is a Grignard reagent. Okay, let me write it like this. This is a Grignard reagent. So nitrile, when reacted with Grignard reagent in the presence of dry ether, we should give you a dry addition compound. So this R dash, what will happen? It will react at this carbon. Okay, at this carbon. So what will happen? Just see R, C, R dash. Okay, then double bond N, Mg, X. So this is our addition product. So this is our addition compound. So this is the addition compound which is formed, which will undergo hydrolysis, which will undergo hydrolysis. Okay, when it is undergoing hydrolysis, what will happen? Yes, what will happen? Water molecule will be added. Okay, water molecule will be added. So here across this double bond, okay, here your C double bond. So it will undergo hydrolysis and here your oxygen and here your OH. So H plus and this will added. OH plus OH you will get here. Okay, so you should get a ketone here. RC R dash double bond O plus Mg X and OH. Okay, so this is the reaction. Okay, this is the reaction. So this will undergo hydrolysis. So addition compound will undergo hydrolysis and upon hydrolysis it will give you a ketone. So nitriles, what we are doing, we are reacting it with Grignard reagent. Okay, so Grignard reagent. So R dash will react at this carbon and what you are going to get, you are going to get a addition compound. This addition compound upon hydrolysis will give you a ketone. Okay, so ketone is the main product which is obtained. Fine. So let us see one example now. Let us see one example. CH3, CH2, C, triple bond N plus C6H5 MgBr. Okay, giving you in the presence of dry ether. So what will happen here? Just see. So this C6H5, yes, so this will attack here. Okay, this will attack here. So what you are going to get? CH3, CH2, okay, CH3, CH2, C, then C6H5, double bond N, MgBr. Okay, so this is my addition compound. This is my addition compound. What is the name of this compound? Starting product. It is propane. Starting reactant is our propane nitrile. Okay, propane nitrile. And this is phenyl magnesium, phenyl magnesium bromide, phenyl magnesium bromide. Okay, so this is our phenyl magnesium bromide. So propane nitrile, propane nitrile, when it reacts with your phenyl magnesium bromide in the presence of dry ether, will give you a what? Addition compound. This on hydrolysis. This on hydrolysis will give you what? It will give you a ketone. It will give you a ketone and MgOH and X. X is what? Your Br. Okay, X is your Br. So what is the name of this compound? Can anyone tell me? What is the product obtained? What is the name? Anybody knows? What is the name of this compound? Try. So you have two groups. Okay. One is the ethyl group. Another is the phenyl group. So which will come first? Which will come first? Ethyl will come first, right?
Ethyl will come first.
Yes. Ethyl, phenyl, ketone. Okay, so this is the name of the compound. Or you can also write it as 1-phenyl propanone. Okay, propanone. Fine. So like this, you have to write the reaction. So when nitriles, when they react with Grignard reagent, okay, in the presence of dry ether, will give you a addition compound. This addition compound will further undergo hydrolysis to give you what? The respective ketone. So what is happening here? Your C6H5 is reacting here. So this bond will attach here and this will attach here. So what will happen here? CH3, CH2, C. Okay. Then C6H5. Then what you can see? A double bond. So and N, Mg, Br. So this will go and attack here and this will attach here. So this will undergo hydrolysis. The upon hydrolysis, whatever the bond is there across this, this will leave and here your double bond will come. So it will be CH3, CH2, C6H5, C. Okay. No, here it is no C6H5.
Salicylic,
Here's
yeah.
yeah. So here this is the C6H5. Just a second now. Okay, so CH3, CH2, C, C6H5 and C double bond O. So this is our ketone and your Mg, Br and OH is the side product which is obtained when you are reacting with the Grignard reagent. Is it clear? Are these both reactions clear? So two reactions we have seen. One is uh, from your acid chlorides or acyl chlorides and the second is from the nitriles. Okay, fine. So from this method also from nitriles we can prepare both. Okay, aromatic as well as aliphatic. This what ketones can be prepared. So in acid chlorides also from acid chlorides also we can prepare both aliphatic as well as aromatic ketones can be prepared. Okay, fine. So from nitriles is also important. Mark this as important. This is important. From nitriles also it is very important. Fine. Okay. Next is from benzene or substituted benzene. Next is from benzene or substituted benzene. So from this aromatic ketones can be prepared. Okay, we can prepare aromatic ketones. So aromatic ketones, it can be prepared how? It can be prepared by treating your benzene. You have to take benzene and you have to react it with acid chlorides. Okay, we have to react it with acid chloride in the presence of anhydrous aluminum chloride. In the presence of what? Anhydrous aluminum chloride. Okay. And so this is a catalyst used. Anhydrous aluminum chloride is the catalyst used and CS2 is the solvent. Okay. Carbon disulfide is the solvent which is used. Okay. What we are going to get? We are going to get a aromatic ketone. What we are going to get? Aromatic ketone. So benzene. Okay. Benzene. So this name reaction is nothing but your Friedel-Crafts acylation reaction. So what? So this group, okay, this group is introduced here in the product. Okay, this group is, so benzene, you have benzene and you have C double bond O Cl. So what will happen? This group, okay, in the presence of what you are going to get, your benzene and your C double bond O R. So this is your acetyl group. Okay, acetyl group is introduced here. So you get some aceto derivative. Okay, you get a aceto derivative. So benzene, we are going to react it with acid chloride in the presence of anhydrous aluminum chloride, which is acting as a catalyst. Okay, and the solvent used is CS2, that is carbon disulfide. We get a corresponding ketone. And this name reaction is called as what? Friedel-Crafts acylation reaction. Okay, Friedel-Crafts acylation reaction. Is it clear? So another
Yes,
name
ma'am.
reaction. So please note this down. Okay. So organic chemistry, you have to note it down. Okay. Fine. Uh, so let me give you an example. You have to tell me the answer. So benzene I have taken plus CH3 C double bond O Cl in the presence of anhydrous aluminum chloride and CS2. Okay, tell me the product obtained.
Benzene, single
Hmm.
bond C, double bond O,
Yes.
single
Hmm.
single bond CH3,
What is the name of the compound?
acetophenone.
Yes, acetophenone. Okay. So we are taking benzene. We are reacting with acetyl chloride. Okay, we are reacting with acetyl chloride in the presence of anhydrous aluminum chloride and CS2. Okay, we are going to get a acetophenone. We are going to get acetophenone. So let me see one more if I can. So benzene plus, mm, yes.
Benzene,
Hmm,
C double bond O, single
hmm,
bond C6H5.
hmm. So this is what? What is the compound name? It is a benzophenone. C6H5 is
Yes,
also
ma'am.
your benzene, right?
Yes,
C6H5 is
ma'am.
also your benzene. So it is a benzophenone. Okay, it is a
Yes, ma'am.
benzophenone or it is diphenyl ketone or it is diphenyl ketone because C6H5 is also a benzene ring. So, uh, and this is your benzoyl chloride. So your benzene, when it reacts with your benzoyl chloride or any other chlorides, you'll get respective ketone. Okay, so we can yield from this, we can obtain what? We can obtain your R. Okay, it can be alkyl group or it can be a aromatic ring also. Aromatic substituted chloride. So this is a Friedel-Crafts acylation reaction. Okay. This is not there for your syllabus. Okay. So we'll keep this. So these three are there for your syllabus. Okay. So these three, you please practice them. Okay. So let me give you some. Okay. So let me give you some questions. So you have to write the structure of the products for the following reactions. Okay. So whatever reactions we have studied till now, so I have taken some questions from there and you have to tell me, okay, you have to see what type of reaction it is undergoing and you have to tell the answer. Okay. And everybody has to answer this one by one. Okay, everyone has to answer this. So this is the first question. Second one is C6H5 CH2 twice cadmium plus. Okay, who wants to answer the first one? Who wants to answer the first one? Okay, okay, Rubna, you can tell.
Benzene,
Just a second. Benzene.
single bond C,
Hmm.
double bond O,
Yes,
single bond CH3.
yes. What is the name of the compound?
Acetophenol,
Yes. Can you tell me what type of name reaction this is?
Federal Crafts
Yes.
acylation reaction.
Yes, it is a Friedel-Crafts acylation reaction. Very good.
Reaction.
Yes, very good. Okay. Next question. Who wants to answer? Yes. Next question. Who wants to answer? I want some other person now. Saubhagya? Yes. Try. So, okay, whatever reactions we have seen till now. So from that only related it is. Okay, but now we are studying separately. Okay. So you have to apply now. You have to think little. So what is okay by taking this reagent? Okay, this is undergoing this particular reaction. So like that you have to think. So tell me, yes, anybody who wants to try the second one? So this is what you can see here. This is a acetyl chloride, right? This is a acetyl chloride. So this is a acid chloride, right? So this is a acetyl chloride or acid chlorides, right? Generally, they are reacting with what here? Dialkyl cadmium, right? You are having a alkyl group and a cadmium group. So what it is undergoing? So I'll write it as dialkyl cadmium, okay, generally. So what I'm going to get? Yes. So the side product will be CdCl2, right? And here
Yes,
I'm going
ma'am.
to get what? I'm going to get CH3, C double bond O, right?
Single bond
Then, yes, wait,
C6H5.
single bond, yes, this 6H5, CH2, okay, CH2, we'll write it, okay, we'll take it as C6H5, CH2. No, CH2, C6H5. Okay. So it will be CH2, CH2, C6H5. Okay. So this is the compound. This is the compound. And we are going to get this particular. So this is a, what it is. This is a benzyl group. How it will appear for you? I'll show you. Okay. So this is CH2 and a benzyl group. So CH2 with a that is a benzene group, It is called as benzyl, right? So we are
Yes,
having,
ma'am.
so it is a benzyl methyl ketone. Benzyl methyl ketone. So this is our product. Okay, this is our product. So next one you have a alkyne. Okay, generally I'm telling you alkyne. This is a propine. Okay, we have a propine and we are reacting with HgSO4 in the presence of dilute H2SO4. What we are going to get whenever we are having other than alkyne, we are going to get, if you have only alkyne, then we are going to get aldehyde. If you have other than alkyne, then we are going to get a ketone. So what it will be? It will be CH3, C double bond O, CH3. So we got a acetone. Okay, we'll get a acetone. So we have seen from from alkynes. Okay, in general reaction, last class. So in last class we have discussed. So when we have a propine, okay. So what in the presence of HgSO is what? CH3, okay. CH triple bond CH. If you have this, you are going to get aldehyde. If you have other than this, then you will get a acetone, ketone. Okay. Last one. Last one. So you have a methyl substituted product and you are going to do a chromium, this test, chromyl chloride test. So this is a etard reaction. So this is a etard reaction. Okay. So what will be your
Yes, ma'am.
product obtained? Your, this is a specifically etard reaction is for aldehydes. So your methyl group is converted into aldehydic group. So this is a para nitropenzaldehyde. Okay, para-nitropenzaldehyde. Is it clear, everybody?
Yes, ma'am.
What about others? Others are sleeping or what? Nobody is responding. Yes. Did you
Ma'am, last
understand? If you
example,
want me
can
to
you
explain, I'll explain you again. Okay, if you have which one? From this
last
example, fourth
example?
one,
Yes, ma'am.
you are only no. Okay, wait. See here, we have seen etard reaction. Okay, now what is etard reaction? Etard reaction we have seen in the previous class. Okay, etard reaction is what? It is basically we are doing etard reaction for only the preparation of aldehyde, right? From etard
Yes,
reaction.
ma'am.
So what we are doing here, we are taking a methyl substituted benzenes, right? So we have a methyl substituted benzene. So this is just a side, okay? This will not affect anything. This will not affect. We should see only at this methyl carbon. So what we are going to do, we are going to react it with chromyl chloride. After reacting with chromyl chloride, we are going to get a intermediate product, okay? That we have skipped here because we are interested only in the product. Right. So what we are going to get? We are going to get CH, okay, O, Cr, O, H, Cl2. So this is the twice. So this is our chromium complex, which is we are going to obtain. So this will not affect NO2. We have to write it like this only. So this is the intermediate product which is going to obtain. This will undergo hydrolysis. Second step is hydrolysis. Upon hydrolysis, what will happen? Whatever this group is there, that is converted into like we will introduce a oxygen atom there. And what we are going to get? We are going to get a aldehyde. We are going to, so upon hydrolysis, this will a side product and we are going to get a oxygen. That is, we are going to get what? Aldehyde group. So this is etard reaction is what? Etard reaction we are going to do for the preparation of benzaldehyde only. So upon hydrolysis, your complex group is, okay, it is getting hydrolyzed to a aldehydic group. So this is the ITARD reaction. So ITARD reaction is mainly done for methyl substituted compounds. Okay, for methyl substituted compound. Is it clear?
Yes, ma'am.
Okay. Okay, Charan and Baby has replied. They have understood. Okay, fine. Okay, so Bhagya has also understood. Fine. So these were the four things which we have seen. Okay, so these were the four questions which we have seen. First one is different. If you want, you can try this first one. The alkyl group is different. Okay, if you want, you can try the first one. First one, benzene, then
Single bond C, double bond O,
yes,
single bond C2H5.
yes. Okay, so here, so this is the product obtained plus HCl. So this is a Friedel-Crafts reaction. So rest all questions are the same. Okay, fine. So what's the time? So let us start with the physical properties. Okay, next is the physical properties. So first physical state is that. So physical states, methanol. Okay, the first one, methanol. Methanol is what? It is a gas at room temperature. Okay, and it has a very bad smell. Methanol, it is having a very bad smell. The bad smell means it is having a pungent smell. Okay, pungent smell means very dirty smell. Okay, and this is a volatile liquid. It is a volatile liquid. Volatile liquid means what? If you keep it open, it will escape it out soon. Okay, it will go like your this uh, acetone bottles. Okay, your nail polish remover. So if you keep it open, it will evaporate, right? So same way, volatile liquid means it will evaporate soon. Okay, it will evaporate soon. So it is having a very bad smell. It is a volatile liquid. Okay. And its boiling point is 294 Kelvin. Okay. It is a 294 Kelvin. And the higher aldehydes, okay, and ketones are liquid. So this is a gas. Methanol, it is a gas. But as you go to your higher aldehydes, okay, as the you move for higher aldehydes, so your higher aldehydes and ketones. So these can be your liquids or they are in solid state. Okay, at room temperature. So at room temperature, they are in liquid or solid state. Okay, so this is about your methanol. Ethanol is also a volatile liquid. So this is also a volatile liquid. So next is your boiling point. Next is your boiling point. So if you compare the boiling points, is it given? Table is not okay. So if I give you a table, so take compounds, okay, boiling point and molecular mass. So N-butane, methoxy, ethane, propanol, acetone, and propane 1-ol. Okay. So this is 273, this is 281, 322, 329, and 370. This is 58, 60, 58, 58, and 60. Okay. So what you can see here, N-butane, it is the hydrocarbon. Methoxyethane, okay, it is also a what? Methoxy substituted hydrocarbon. Then propanol is a aldehyde, acetone is a ketone, and propane one all is a alcohol. Okay. Now, when you compare the boiling points, what you can see, the aldehydes and ketones, okay, are okay. So you can see as compared to your hydrocarbons, okay, and methoxyethane is a ether, right? So methoxyethane. So as compared to your butane is what? CH3, CH2, CH2, CH3. Okay. Then ether is methoxybenzene. So CH3O and CH2, CH3. So this is your methoxyethane. Third one is propanol. CH3, CH2, CHO. So this is propanol. Fourth one is acetone. CH3, C double bond O, CH3. And fifth one is your propane one also. CH3, CH2, CH2OH. Okay. So when you compare this, okay, you can see that aldehydes and ketones, your aldehydes and ketones, they have higher boiling point, okay, as compared to your this what your ethers and hydrocarbons, okay. And the molecular masses are also same. You can see the molecular masses are almost same. It is 58, 60, 58, 58, 60. So it is almost same when you compare the molecular masses with other. But why the aldehyde and ketone are having higher this? Because of the weak dipole-dipole interaction. So because of the weak dipole-dipole interactions, the boiling point of aldehyde and ketones are comparably high as compared to other this what hydrocarbons, your ethers, etc. Okay. But you can see that, however, in case of your alcohol, okay, the boiling point is, okay, it is higher. Why? Because in alcohol, there is a strong hydrogen bonding, intermolecular hydrogen bonding is seen. So because of that, the means aldehyde and ketones boiling point are slightly lower as compared to alcohols, because in alcohols there is a presence of intermolecular hydrogen bonding. Okay, so as you see, the molecular masses are same, but still the boiling point are changed. Okay, why? In aldehydes and ketones they have uh, higher boiling point. Okay, because they are having weak dipole-dipole interactions as compared to hydrocarbons and ethers. Is it clear? Is it clear about boiling point?
Yes, ma'am.
Okay, fine. So the other things, so we have left with solubility, okay, and some chemical properties. So this we shall discuss it in the next class. Okay, any doubts up to here?
No
No, ma'am.
doubts, ma'am.
Okay, fine. So I'll end the session here. Okay, we'll meet in tomorrow's class. Thank you.